FFT Analyzer is a standard module included in the base price of AudioTools. It is also available as a standalone application. This demo is recorded in AudioTools, although the standalone application has nearly identical features. FFT, or Fast Fourier Transform, takes a time-varying input signal and transforms it into a frequency spectrum. The algorithm used in Studio 6 Digital's FFT Analyzer provides the same quality measurement results that you would find in any other hardware or software-based FFT Analyzer. Let's take a quick tour of the FFT Analyzer's interface. This is the main graphical display that you will see when the analyzer is being used. I'll tap the play button, which will start analyzing the audio coming into my input device. Frequency is displayed on the x-axis, and amplitude in dB/SPL is displayed on the y-axis. By dragging one finger onto the screen, I can bring up a vertical cursor, which will display the frequency and amplitude of any point in the spectrum. To remove the cursor, simply slide it off the screen. If I want to focus in on a specific frequency region, an outward two-finger pinch gesture will zoom the graph either in the frequency or amplitude domain. To fit the entire measurement on screen again, simply double tap. The top right corner displays the broadband SPL value of the current measurement. This photo thumbnail button will take a photo of the current measurement and save it to your iOS device's photo roll. Moving to the bottom of the screen, you will find the play-pause button to start and stop analysis, access to the save and recall screen, built-in signal generator, and setup menu, all of which we will cover later in this video. On the main analysis window, you will find two selectors, which will allow you to change frequency smoothing and the decay mode. FFT smoothing runs a linear smoothing function. Each point is smoothed by information from an octave-wide frequency band centered around the current point when in octave mode, for example. Smoothing options from 1 octave to 1/24th octave are available. I'll change the smoothing to a full octave, and now to using no smoothing at all. The other selector lets you adjust the decay mode. The decay times apply to the graph dB values. A decay time of 1 second will cause a point to decay at the rate of 20 dB per second. If I change the decay time to 4 seconds, the decay rate will now be 5 dB per second. There is also an option for an average mode, which will take a linear average of all of the readings, as well as a peak hold mode. Tapping the reset button will reset each of these modes. Tapping the small sine wave icon will instantiate the built-in signal generator. With this, you can generate a sine or square wave tone, as well as a pink or white noise, through the output of your audio device. Tapping the wrench icon will bring up the FFT setup menu. From here, you can customize how the FFT Analyzer operates. The FFT Analyzer has two options for frequency range: low frequency and full range. Full range is what we have seen up to this point in the video and displays a 20 Hz to 20 kHz range. If I tap the low frequency range, I can now measure frequencies from 5 Hz to 3.1 kHz. The low frequency mode is especially useful when you need the most resolution in the lowest octaves of analysis, measuring a subwoofer's response, for example. The audio monitor switch will let you monitor the audio that is coming into the audio interface through the output. The FFT type selector will allow you to change the FFT size used for analysis. A higher number of points will give you additional frequency resolution at the expense of update speed. FFT sizes from 2048 to 32,768 are available. An additional mode, equal points per octave, is also available. This mode is best used with steady-state signals such as pink noise, but provides excellent resolution across the frequency spectrum. The peak tracking and SPL readout boxes will change how the FFT Analyzer screen will display data. Peak tracking will track the FFT bin with the greatest energy. It can either be displayed on the FFT graph itself with the cursor option, or in large type with the large button. The graph scale section will let you manually set the dB scale and frequency scale. It will also let you change the frequency scale from log to linear. Finally, you can lock the graph scales here. When lock is on, the ranges cannot be changed except by the setting fields. You, however, always can pan up and down and get the plot on the screen. Double tap and auto scale on recall are also disabled. Changing the SPL readout will adjust the broadband SPL being used. You can pick flat, A-weighted, or C-weighted. You can also select a flat A or C weighting filter to be applied to the entire FFT analysis. If you have purchased the reference curve option, you can access the reference curve menus from the FFT setup menu. Please see our video for details about reference curves. The difference mode will allow you to compare the frequency spectrum of a stored measurement with the currently measured signal. I'll start by capturing a reference measurement. Now I'll tap the Save Recall icon and save this measurement as my reference. Recalling this measurement normally will display the FFT of the saved response statically on screen, and my current measurement can then be compared to that. To turn on difference mode, I'll navigate to the FFT setup and tap the On button. You'll see that there is only one graph displayed and it is turned green. The name of the reference measurement is still displayed in the upper right-hand corner. Dragging my cursor on the screen will now show you the dB of the reference measurement, the current measurement, and the delta between them. Tapping the invert mode will reverse the subtraction order. A normalize option is available to relate the broadband SPL of the reference measurement to the current measurement so you can compare relative spectral differences as opposed to absolute level differences. There is often the situation where you'd like to take numerous measurements around a location for an average, and then compare that average to a further individual measurement. This is exactly what the average plot switch lets you do. You can see that the difference being measured is actually the difference of the current measurement from the average of the 4 recalled measurements. This option works with difference mode turned off as well. If I turn off the average plots option, you can now see the 4 individual measurements which made up the average plot. There are options available for customizing the analysis with the windowing settings. Windowing accounts for the fact that each FFT sample is made up of a finite amount of points. Whenever we measure a non-periodic signal, the on and off ramps of the sample cause spectral splatter. In the FFT setup menu, you are able to pick 3 of the most widely used window functions, which multiply the signal by a tapering function to reduce this leakage. The final option available in the setup menu is to adjust the FFT overlap. Overlap controls the number of samples that are collected before an FFT is run. When set to 0, the entire buffer is loaded with new samples before a new FFT is allowed to run. For example, with 32K FFT running at a 48K sampling rate, that's 32,768 samples, or about 2/3 of a second. So the screen would only update with new information that often. If the offset were set to 90%, then only 3,276 new samples would be collected before running a new FFT. With this setting, the screen updates much more often and is much smoother. AudioTools, the FFT module, and the FFT standalone app works with all current iOS devices and all audio input devices supported by the hardware.